I'm going to say, first of all, thank you so much for inviting me today. Much appreciating it. I'm going to be talking about the Driving the Electric Revolution challenge in part, but mainly about the technologies behind it. And I wrote down the question because I put it at the end, but I want to remind everyone where I'm going is, where should the next PEMD semiconductor funding be focused? As a bit of a background, we did this about 5 years ago at the STC. We came along and we said, well, what should we go and do? Where should we go and get funding? Where should we put it? And it was a part of that enabled the funding into this program. I work for Innovate UK, specifically Innovate UK Business Connect. And we exist to join innovators, people, companies together. The worst slide ever, I think. But it's absolutely brilliant, highlighting just how many different areas there are to go and assist companies and organisations. The two sides of Innovate UK, funding and support. So Driving the Electric Revolution is funding, it's challenge-led. It was companies and organisations saying, we have this problem, we have this challenge, we have this requirement. How can we improve it? How can we assist on it? And on the other side, we have Business Connect, who go and promote, highlight that, network the organisations together. I think this is a brilliant time as well, just to also go and highlight what other supports we have, or you have, sorry, not we, you have to go and assist. The catapults, I work very closely with the Compound Semiconductor Applications Catapult, but there are many out there who are very specific. They have equipment, they have resources, they have open door policy to go and help you go forward. We have things like the Global Expert Missions, something brilliant to look out for. I was in Korea, or Republic of Korea, very recently, where we're assisting several companies look for new markets in semiconductors, work out what opportunities we had there. They develop onto GBIPs, where we actually go and try to do business-to-business development, typically and often funded through the Innovate UK funding processes. So it broadens your market. Our sales, Business Connect, which I'll highlight again in the next slide, and things like Innovation Exchange. Just completed one of these with an organisation where they said, we've got this challenge and this requirement, and we found using this 16 organisations who could specifically assist them in this. So, quick reminder, Innovate UK Business Connect, it's PPP. We network people, products, pounds, money together. And we do it over a cross-sector part. My focus, said power electronics, machines and drives, but that covers everything from satellites, communication, tractors, farming, manufacturing, process lines. So we have this brilliant capability where if you pick out one of these, they will mention in a network with everyone else. So, driving electric revolution. Basically, there is a requirement for power electronics, machines and drives, and also semiconductors. A machine is basically a motor or a generator, and typically large, as in 30 kilos to maybe 3,000 kilos. And following on from 5 years ago, where we were doing an event very similar to this, we had £80 million, which we have invested over many challenges to basically address the supply chain. That was the reality of it. It wasn't to go and assist these companies develop their specific product. It was the reality that we require a broader supply chain. We require the components, the parts, the devices that will enable this multi-billion products to develop. So, why focus on this? What's the point? Why do all this? Well, quick highlight here is that 3% of all the world's electricity goes to mining, which is a monstrous amount. And most of that goes to crushing rocks. There's large motors out there that crush rocks to go and get out very, very small amounts of metal. 3% of all electricity goes in to do that. And we want to expand that mining. We want to go and continue doing it. And reducing the efficiency and capability of that brings about, well, in reality, it's either two things. One, we get closer to net zero. Two, we can reduce the cost of those products. Or three, we can go and expand on those products to bring about more product output. And that covers a massive area of development that needs to be addressed. Power electronics, that's the part that goes and controls these motors and powers them. The electric machines themselves, the materials, the magnets, the bearings, the interfaces, and the drives. That's the actual specific coding and delivery system to actually make these motors work. If you can improve all of these parts, you can bring about a dramatic improvement on manufacturing processes. And just to bring it, mining is a bit distant here. Production lines, conveyor belts. Conveyor belts use all of this part. If you can bring about an improvement in efficiency of your conveyor belt on a production line, you bring about improvement in process. And therefore it covers, we've got graphics here, everything from transport to aerospace to rail to power generation. And to be able to do this, we have to cover everything. And this is, again, shows how wide this part is. You'd love to go and say A to Z. Everything from the raw material up to the system integration. Now, this easily makes you think of, well, this is the process line. But these are all the separate parts that are multi-level as part of the supply chain. The raw mineral, well, that could be a steel, a cobalt, a copper, an aluminium. The process material is how do you go and improve that process, or where do you go and get those process materials to come in? Sorry, not the slide. The components, that's the subcomponent, let's say just the board, just the power electronics on site inside the module. The component side where you've got the whole drive joined together and then integrating all the parts together. And we've also got the recycling part there. And that's one of those key areas. And also I'd like to add remanufacturing. Recycling should not be considered independently of remanufacturing. So there's a massive process, massive supply chain that needs to be improved or addressed or strengthened. Now this is a nice graph. This bottom axis is quality of research paper versus quantity versus quality of research papers. You see Italy, United Kingdom, United States are in the excellent quadrant. We are one of the 3 recognized locations to do integrated electrification. And thank you to the University of Sheffield for this graph. So it shows that we have the capability here in the UK to go and do this. We are seen as being leaders. We are pulled upon to go and push it forward. Now, we've been doing this for 4 years. This specific tranche of funding completes end of this financial year. But we have addressed 91 projects. We are currently getting the feedback on their success stories, which we'll be promoting end of this year. But we have seen significant changes and improvements in these companies, and this report here will highlight some of those organizations in there that are utilizing it. Additionally, we're also looking at the legacy. So this is not just the legacy of those companies going forward, but it's also the legacy of the fact that we now have a Driving the Electric Revolution IC Centre, Industrialization Centre, who specifically have equipment, processes, and capability to assist companies with the assistance of several universities. And the other part is jobs. We have an industry here that has a requirement for upskilling, side-skilling, and highlighting the opportunities here to a new audience. We have to promote this to STEM, and we are doing that. I was working with McLaren Applied recently, highlighting just how fantastic their engineers are and how the new generation are developing their products there. So STEM is going to be a critical part that we need to develop. So we have the Electric Revolution Skills Hub as part of this. And the reason I say legacy there is that they will continue from several years after the completion of this project. The other side of the PEMD I just want to highlight quickly was the semiconductors. And I'm doing this because this is an upcoming part. The UK Semiconductor Strategy has been recently released. There is a key theme that we need to go and develop this process, this technology. We have organisations here in the UK that are being called upon, utilised by the world. We have studies, advisory panels, and organisations and companies that are promoting our technology capability here. And we have funding to go and promote this. But how do we go and continue leveraging the strengths that we have? First, I just go and like to highlight what we do have as strengths. The UK has many semiconductor design houses, a very, very strong intellectual property on development of chips. And we have a fantastic, what's known as fabless process. We are called upon by many organizations across the world to go and utilize these companies' capabilities. Part of that is that we have, it says there, 8% global market share on compound and novel material semiconductors. This is seen by the catapult, the Compound Semiconductors Application Catapult, that these compound semiconductors and our understanding and use of them is seen as a key focus and capability here. And the reason for that, well, the development of electrification requires higher voltages. Automotive is moving from 800 volts now, close to 1,000 on some cars. Higher frequencies and higher currents, all to bring about improved efficiency of motors so you can drive further, more efficient wind farms. And we also have a massive research strength at the universities as well that's leveraging into this. So we are seeing a big focus on the semiconductor and our strengths for the future. So I drop this in to go and say, we have a lot of this in reports. Please come back to me and I can highlight some of these parts if there's any specific information we talk about. So, future. I repeat, my question is going to be, where should we put funding? If we go and continue, if there's a continuation in PEMD, continuation in semiconductors, I'm here because I'm interested to know what areas, what specific areas should they be put into? So previously it was supply chains, skills development. But I wanted to just highlight some of the technologies. Now, some of these, many of you I'm sure know about already, but I want to highlight from my personal point of view some of the complexities out there. So I'll take magnet recycling. Rare earth materials make up magnets. We get a magnet, we epoxy it into a motor, we run the motor, and it will last, let's say, 10 years or longer, hopefully. How do you get that magnet back out again? That magnet is full of a critical mineral that is in a limited resource that we would like to go and reutilize again. So we have a source of this material here in the UK in cars that will, as an example, that will be available to us when those cars have completed their life. But a reminder, magnets are inside steel motors. If you just crush those steel motors, those magnets will stick to the motors themselves. They will stick to the machines. They will be damaged or contaminated by the other materials around it. So should we be working to go and improve the method of demanufacturing, breaking up the motors? Should we be looking at methods to ensure that magnets are put into the motors in a more easy to remove process. A better title for that would be good as well. Or does there need to be, and following on, if you have got the magnets out, what process could be done to return those rare earth materials out of those magnets? Do we just use the magnets as they are, or do we reprocess them? Remanufacturing, actually a word I really quite like. So rather, this is not a case of just getting an electric motor and using it, say, out of a car and, say, using it on a production line. This is, for example, getting an electric motor out of a train, reassembling it and making it better. The key word from the remanufacturing is you need to make that motor better than it was before, redesigning it, using new components. So rather than just starting from scratch, reusing that process in again. Rare earth-free motors. Should there be more development on this, or should we be just using them more often? So the point of this is that they are likely less powerful or less efficient, but they are free from the rare earth. Again, limited resource. Is there some way that in some instances we should be using rare earth-free motors more often? Should there be more development on those motors to make them better for certain areas and certain markets? How can we optimize our application of these? And metals. Well, I wrote a report on this quite recently, so I've got a few too many bullet points here. But steel isn't just steel in this, as an example. Thank you. Steel isn't just steel. We've got things like electrical steel, which has small eddy currents, or reduced eddy currents. We have things like, should we be using aluminium windings instead of copper windings? But what are the downsides to that? How can we go and optimize the use of those metals? Should we be going back to the rare earths, how can we optimize the rare earths? How can we ensure that we have a supply of rare earths in the future? And is there any way that, going back to the semiconductors, are any specific compounds or metals that we need to be have better resilience on to have those materials around? Now, on the semiconductor side, we have invested money on the aim on scaling up the semiconductors. So we have been very specifically on looking at some of these material sides and futures. So should there be more money on semiconductor development? Is there areas that we should go and focus on more? So this is my final slide where I've just repeated my question again. Where should the next PEMD semiconductor funding be focused? So this is power electronics, machines and drives, and semiconductors. Is there any specific areas from your expertise that you're going and saying, where should we put it? Is it on a specific materials? Is it on processes? Is it on skills? Is it on training? Is it something that we are specifically missing in the UK that we have a requirement for future development into future industries? We'll complete there. Thank you very much for listening to me today.